Good morning, everyone on the West Coast. Good afternoon to everyone on the East Coast. Thanks for joining. Today we've got a great presentation from Scott Sakai, the SDSC Senior Security Analyst, on Indispensable Security, tips to use SDSC's HPC resources securely. It sounds like it should be a great talk. Before we begin, I would like to talk briefly about or bring people's attention to the Exceed Code of Conduct. I won't dwell on this, but if you want to know more, or if you have some issues that you'd like to report, just go to the Exceed user portal and do a search on Code of Conduct. Also, we will be making a recording of this webinar available after the presentation. And with that, I'll hand it over to Scott. I'll stop sharing, and Scott, you can go ahead and start sharing.
Thank you. Thanks, Jeff. Let's see if I can do this. How's that?
Yep, looks good.
Perfect. All right. Well, first, I'd like to start off with a thank you. Thank you to all of you. I know that security can be boring. It's got dry material. It can also be a little bit frustrating. You have conflicting and sometimes even arbitrary sounding requests. And then finally, it can also be intimidating because there's hostile or unfamiliar terminology. But your interest today says you care about protecting your research. That's a good thing. So let's talk a little bit about this presentation first. I'm hoping that this presentation is approachable, and there are 8 short breaks for questions. So if you have questions, please make use of them. Don't be shy. I'd also like it to be actionable. So the information that we give you or that I give you today is something that you can take back home into your institution and actually put it to work. And then finally, I'd like to make sure that it's reasonable. That is, we don't want to have this whole usability versus security argument. Nothing too crazy. And a little bit about myself. I'm a senior security analyst at SDSC. I've been working with SDSC since the early 2000s and started working in HPC security in the mid 2000s. And I'm interested in the intersection of people and security, which is why I'm here today. So let's take a little bit of a journey, philosophical journey into security. It's nice to know where we're coming from so that we know there's a background as to why we're making these strange requests. And remember, security is a journey, it's not a destination. So with that, let's get on our way. Starts with a question, why me? And I get this in 2 different contexts. The first is first-time victims. This is somebody who has never had an interaction with security before, and then suddenly something went wrong. I show up at their door and they go, oh no, what happened? Why me? And then the second is future victims. And these are people that we notice are doing strange things that are not exactly appropriate. And then I say, can you stop that? Can you do this instead? And they say, well, why me? And it's often followed by but. Word but. And something like, I have nothing interesting, or I have no sensitive data, or my research is public. Well, the answer is the same to both scenarios, and that is, in order to see that you have nothing interesting, the attacker must first get in. And sometimes the attacker knows exactly what you have, and it's exactly what they want, and it's probably not what you think it is. And then finally, it's also possible that there's no attacker at all, and just you got a bad dice roll. Something random happened. So let's talk about what can go wrong. It sort of depends on the circumstances, but here are some possible outcomes. You have data corruption, data deletion. That's a common one, especially now. Especially now with you may have heard in the news that one of our other UC campuses ended up paying a ransomware. Someone else can publish your work. That's kind of embarrassing. And also the integrity of your research can be called into question. You publish something controversial and then someone will pop up and say, this research is invalid because I broke into their account and I've had access to it and they didn't even notice that I was there. We don't want that either. Another common outcome is that the credentials that are present on your account on our machines, which shouldn't be there anyway, but some people do this anyway, they get used against our partners and affiliates, or the machine itself is used against our partners and affiliates. And this gets really expensive because every victim institution, every victim machine requires a incident response activity, and that activity involves usually about a half dozen to a dozen people. Multiplied across all the organizations, it gets expensive really fast. And we all look bad because there's a loss of reputation. It's like, oh, these academic people, they can't keep their machines secured. But I think the biggest concern of all is that, the biggest worry of all is that decisions in policy may be made based on research derived from corrupted data. And that's a scary thought. So a little bit further, knowledge is power, and unfortunately the attackers have the knowledge. And we can't predict what each attacker's goals and motives are. We don't know what they're after. And we also don't know how they're going to attack us and what tools they have. And we certainly don't know how much resources they have to throw at our defenses. It could be a single person at home, or it could be an entire state-sponsored operation with hundreds of full-time employees whose sole purpose in life is to go and throw attacks at us and get in. But we must still keep them at bay. So let's take a tangent. Let's take a tangent here. Head-on defense is really hard when you don't know what your adversary is up to. You can't say, well, they're after my data, so I'm going to protect my data, and then nothing bad's going to happen to me. Taking this into real life, let's take an example here. Here's a mall parking lot. You know, you go to the mall, you go shopping, you buy a lot of stuff. You don't want to carry it around, so you take it back to your car. And conventional wisdom is when you go park at the mall, you don't leave your bags in plain sight. You put them in your trunk, you throw a blanket over it, you do something, as long as it's not shopping, sitting there saying, hey, steal me. Well, what happens if the thief doesn't care about your shopping? So let's say you go back in your car, you sit down, you go, woo, everything's still there. I made it out alive. Then you turn your car on and the engine is just like super loud. The car alarm is going off. The car alarm in the car next to you is going off because it's so loud. Well, what happened? For those of you who may not notice, who don't know, and I don't expect many people to know, that's a picture of a catalytic converter. Every car that runs on gas has one, and they're actually quite valuable on the scrap market. So in this case, in this scenario, the thief went and stole the catalytic converter, and now you have to buy a new one. And they're not cheap either. So, excuse me. The last few slides, yeah, they're anxiety-inducing. You're probably thinking like, the world's over. There's no hope. Well, don't worry about it. Don't panic, because the successful attack doesn't mean game over. What matters are the consequences. And as humans, we have an imagination. So the power of what if, and the mistakes of others who have already gotten bitten, allow us to anticipate many of the possible consequences. And knowing that, we can prepare now, knowing what may come later. So I got a break here for questions, really short break. I'll talk about responsibilities next. I guess it would be put your questions into the chat. I'll give you about 10 more seconds. Okay, I guess we're moving on. So you may have heard this phrase, security is everybody's responsibility. Well, it drives me nuts because it doesn't explain who's responsible for doing what, and also importantly, who's responsible for not doing what. Click. So yes, we're in this together. That means you as the users and us as SDSC. All of the staff in between. So let's model the expectations of a security environment. We have an HPC environment. So here we have an HPC environment. It's got some computational resources. It's got users. Users have data. We draw security around it. It keeps the attackers out. And then SDSC provides the security and everything's good, right? No, not quite, sorry. See, we're in this together. This is a shared responsibility. So yes, SDSC does provide security around its HPC environment, but we also do our best to isolate any bad things happening between users within the environment. And we also have some controls that are available for your use to protect your data from other users. And these are your responsibility. So you're probably wondering, why do we have this? Why do we have these dividers between users? Why do we have these protections within the environment? Well, what happens if one of the users is actually hostile? If we don't have those protections, then they run rampant through the machine and we have a bad day. But hopefully, if everything works right, the extent of the damage is limited to what that one user can do. So let's talk a little bit about expectations. You as a user can expect SDSC to enforce the permissions that get set on your data so that your data is protected from other users. And we'll do our best to protect your account from the influence of other users. And of course, any computational resources that you're entitled to, you can assume that they'll be there. In turn, SDSC expects that you'll protect your account credentials to the extent that you have control. That seems a little lawyerish, but we'll talk about what that means later. And similarly, we expect that you'll protect your data to the extent that you have control. And importantly, we expect that the resources, you'll only do on our resources what you have been authorized to use them for. That means if you have a grant to do research on, or genomic research, you're not mining Bitcoins. So any questions? Oh, I see that, oh my goodness, there's a lot of questions that popped up. I see that there's a question here that asks, how different is HPC security in academia compared to the industry? Is academia an easy target to bad actors out there? Yeah, unfortunately, most of the research that gets done in academia is of the open research type. And so the security controls that get put into the academic types of HPC security are lower than that which you would find in, say, private industry. Part of it is just a lack of resources, but also it's an understanding that in private industry, you have a captive audience. You can turn the screws down and make your users excuse me, make your users' lives a little miserable in turn for more security, because they're not going to go anywhere. And in academia, especially like on our Exceed machines, you can't do that, because if you make the machine too hard to use, no one's going to use it. And now you've wasted your money building a machine where no one's going to come. And generally, academic environments are much larger in number, much more diverse. They're certainly not homogeneous. They're all kinds of operating systems, all kinds of machines. So they're a little bit more difficult to secure than like a corporate environment. Okay, next. I guess I should go up or go next. Oh, and okay, and I see here now there's another question. Are bad actors targeting HPC systems for specific reasons, or is an HPC system just a stepping stone to another target? Both, actually. we have opportunistic attackers that will break in and then use a machine as a stepping stone to go and try to move to other places within SDSC or to our partner institutions. It doesn't happen very often, like maybe like once or twice every few years. And do they break in with specific goals? Yes, they do. The most common one is that they try to use our CPU resources for cryptocurrency mining. But also we've had an incident recently involving COVID-19 research. Okay, anything else? Nope. Okay, so pop quiz. What's the most important thing you can do to protect your account credentials? Is it to choose a password with numbers, letters, and symbols? No, not really. Well, what about to install and run anti-malware software? You're close. That's the second most important. But here's a hint. The most important thing you can do to protect your account is to keep your machine and software updated. That's right. If you're missing out, it should also apply for computers. Security updates help prevent attackers from easily taking control, and updated anti-malware software can detect and stop many tools that are used by attackers. For your machines that use at work, your institution may already take care of this for you, but don't assume that they just do it for you. Please go check and make sure, don't assume. And what about your personal machines, the ones that you have at home, or the ones that you take to work, but they aren't really managed by work? Well, that is your responsibility. It's important to know that SDSC cannot protect your computers, and an attacker on your computer can do anything that you can, sometimes more. It's also important to know that from our perspective, it's impossible if not difficult to tell what the difference between an attacker on your computer and you on your computer when accessing our resources. That's why we take our best. That's why we do it. Excuse me. That's why we try our best to protect users from each other, but only you can protect yourself. So let's take a look at what an opportunistic attack looks like. Sometimes these are called drive-by attacks. And it's pretty disconcerting. So it's like you use your computer normally. Sometimes you may see something obviously wrong, like, oh, here's a fake AV warning when you're browsing the web, or an email that says you owe a lot of money to some place that you've never heard of. And you're like, oh my God, I need to go and see what's in here. And then you open the attachment and boom, there's something wrong. Or you're just viewing the web, you're browsing the web normally, and here there's nothing inherently wrong with this page, but maybe one of the many ads in here has something is up to no good. Usually what happens though is whatever thing happens there, there's some malicious software, and unpatched programming flaws allow that software to run. If they were patched, then it normally nothing happens. But if it's unpatched, yeah, the malware starts to run, and then through a chain of events, somebody or something else has control of your machine. Now, if this happens to you, don't feel bad about it. It can happen even if you did everything right. You know, sometimes the software just doesn't catch the malware, like AV doesn't catch the malware, or there is a vulnerability in the software that hasn't been addressed yet by the people that manage the software. So don't feel bad. So how do we deal with these opportunistic attacks? Well, as I said before, updates. Gotta please keep your operating system and all the software that you use on there updated. If your software is too old to be updated, it's time to upgrade. Yeah, I'm sorry. I know it costs money sometimes, but I know it costs money sometimes, but the effects of not having done the upgrade and then getting a security incident are also expensive. And finally, again, update and run anti-malware. Okay, break 3 for questions. Next, we'll talk about logging in passwords. Okay, I think I'm caught up in the chat. Oh, I see one. Somebody asks, can the use of virtual machines reduce the risk of being attacked from user side? I assume that you're talking about virtual machines in the HPC environment, or is that on the client side? On the client side, sometimes they can, but the virtual machine is still another computer, so it's another piece of software, another operating system that still needs to be kept updated. It's there are attacks that can break out of virtual machines. They usually get patched really quickly, so now you have to keep your virtual machine software patched as well. But it can help, it can hurt, and it's really up to you to decide whether or not the extra effort is worth the benefit. Okay, moving on. So let's talk about logging in and passwords. So your first time logging into an SDSC HPC environment, it's probably going to involve a password. So let's take a moment to talk about what makes a good password. Well, it contains uppercase, lowercase, letters, numbers, symbols, and you change it regularly. Yeah, no, sorry. That's the old advice from our friends over at NIST. Here's a problem. The old rules are hostile to users. They're hard to type. They're hard to remember. Was that a 0 or an O, an I or a 1? And finally, once you've remembered them and you can type it in, great, it's time to change your password. So the new guidance from NIST is no composition rules, no 8-character minimum, and no arbitrary password changes. And then the things that consume passwords need to check the password against a list of known bad passwords. So great. What does this mean for you? Well, the folks over at XKCD have done a good job summarizing this, and I'll pause for a moment to let you digest this comic, or you can take a look over at the URL on the lower left. The short of it is less complexity, longer passwords. They're easier to remember. They're more secure. All right, moving on. So a little bit more additional guidance regarding passwords. Please never use the same password for different services. I know every website requires a new password. Every service, you want to sign up for your discount card, you need to have a password. You want credit card, password, banking. I know, but please don't use the same password for different services. If your password is exposed in one place, it'll get used because you use it everywhere. All of your other accounts will become compromised as well. The attackers know this. Also, please don't share your password with other people. This includes any kind of support staff, real or otherwise. Our support people are never going to ask you for your password. Please don't send it to them unsolicited. And if anybody calls pretending to be support and saying, hey, we need your password, it's not us. Don't give your password out. We don't need it. So yeah, you have a lot of passwords. There are pieces of software called password managers that are designed to securely store passwords on your computer so that you can get back to them and you don't have to remember them. Yeah, consider using one. They help a lot. And depending on what your institutional policies are, it may be okay to write your passwords down if you keep the thing that they're written down on physically secure. And by physically secure, I mean like in your wallet or anywhere that you would stash a large amount of cash. Of course, check with your institution to make sure that this is okay. Sometimes it is, sometimes it isn't. By the way, did I mention, please don't share your password with other people. This includes our support staff and your colleagues. Now, importantly, don't store your password in any electronic form unless it's encrypted. If you're using a password manager, or at least a good one, it will encrypt your passwords, so that makes it okay. But otherwise, yeah, don't do that. Here's some examples of of ways to not store passwords. In a file, I've seen people put a file on their desktop, like a document, a .txt or Word document, put their passwords in it. And I've also seen passwords in shell scripts on our HPC machines. So it's like the workflow generates data, and then that data needs to get off of the machine. So they write a shell script, put their password in there. The shell script executes with as part of the batch job, and then makes an outbound connection, uses their password to log into another machine, and then copy the files over. Yeah, please don't do that. We've seen situations where users will put their passwords in email drafts and then just kind of like leave it in the draft folder. That's also really bad. When an attacker gets into their email account, they look through all of their folders and find the email draft and go, oh, hey, look, here's all the passwords for all the machines that they have access to. We've seen a variant of the first where the passwords are in an Excel spreadsheet, and I've seen it taped to a monitor before. When I said it may be okay to write passwords down, and store them securely. Taped to your monitor is not storing it securely. Sorry. So, another break for questions. So I see that I see a question regarding password storing app. I have a question about, may a system hacking happen for an HPC? What's the most common case that happened for that? I'd like to address that afterwards. And please remind me, I'd like to address that afterwards. I see that there's another question about password storing app. Do you have one that I recommend? As far as recommending password managers, I don't have any particular favorites, but I suggest checking with your institution to see what they have available. Generally, they have like educational discounts or site-wide licenses that can make an otherwise costly piece of software free for you to use. Okay, so welcome back. You've gone through my advice and changed your passwords, and now it's still time consuming to use. You want to log into Comet or Expanse when it comes up. You have to type your password and then you exit out by accident and I have to type it again. It's like, oh, this is such a pain. But SSH keys to the rescue. You may have heard of these. They're awesome. You don't have to type your password every time you want to log in. So everything's good? Well, maybe. Like most things in the world, it's possible to end up with something that works, but it's really insecure or unsafe. SSH keys are no exception. So if you have no idea what SSH keys are, you may have gone. If you had no idea what SSH keys are, you may have gone and Googled it and said, how do I make one of these things? I want to use this. Well, here's some advice that you'll come across. It's up to you if you want to use your passphrase. A passphrase is optional. You can leave the passphrase empty. Please, just no, don't do this. That's dangerous advice. It's going to cause trouble. So let's back up and explain why. A little bit of background here. SSH keys are cryptographic keys, and they're a strange flavor. There's two of them. They come in pairs, and they're really tightly related to each other. One key undoes the encryption that the other key does. So if you have two keys, you have some sort of crypto algorithm. We're not going to talk about what they are. Another crypto algorithm, which we're also not going to talk about, and some message. In a plain text message, you feed it into the algorithm, you add the key. It generates some random looking garbage. It's not actually garbage. You throw it you throw it on the other side to decrypt it, add the key, and out comes your message. So how do we make this into an authentication mechanism? Well, first, let's give these things some names. The key on the left is a private key. The key on the right is a public key. Public key goes on the server, and the private key goes on the client. When you try to log in, the server does a little bit of a dice roll, generates a random number, sends it over to the client and says, hey, can you sign this for me? The client does the signing operation using its private key, generates something that looks like garbage, goes in and then sends it over to the server. The server uses the public key to decrypt the garbage and then comes up with a number, and hopefully the two match. If it does, everything's great. So now you're probably wondering, this private key over here, if it uniquely identifies ties to a public key, isn't that kind of like a password? And didn't you say not to store passwords electronically unless encrypted? Yeah. So please put a passphrase on your private keys all the time. All right, so back to using SSH keys, safety first. Keep your friends close and your private keys closer. This means that they should only be on the computer that you're physically touching. In particular, it means not on our HPC systems. If you have private keys on our HPC systems, this is a good time to get rid of them. And also use a long passphrase. There's passphrases and passwords seem to fill a similar role. However, passwords are usually short, as in like 8 to 16 characters short. Passphrases need to be much longer, like 24 characters or longer. And this is because unlike unlike an SSH login where it's rate limited, an attacker, if they get a copy of your private key and they want to go and start using it, this passphrase is the only thing that will protect your private key from being abused. And your attacker may have a very large amount of compute resources to throw at guessing your password. If it's only 8 characters long, they're going to guess it. If it's 24 characters long, it might be more expensive. It might be more expensive to break it than they're willing to pay. And also, it's okay to use the same key pair everywhere. It's not like a password. If you have 5 different machines that have nothing to do with each other, and you're not concerned about each operator knowing that that you have an account on another machine, yeah, it's fine to use the same key pair everywhere. But only as long as you protect the private key. If you lose control of that private key, your attacker can go to anywhere that private key is valid. So now you're probably panicking. These SSH key things, all these requirements that you're putting on me, it makes them unusable. Like, I have to type that passphrase every time I have to log in. And how's that better than a password? And what if I need to log into something from an HPC system? How do I do that if I don't have my private key there? And you're probably going, this must be really secure because it's a pain to use. All right. Look, don't panic, okay? There's this thing called an SSH agent, and it's here to help you. Its purpose in life is to secure your private key in a decrypted form so that it doesn't live on disk in plain text, but it's still accessible as if it were. And your SSH client, if you're using a modern and reasonable client, knows about an agent and can communicate with it without having you to do too much work. And also, the communication with the agent can be forwarded or proxied. And what that means is that if you log into a server like Comet and you have agent forwarding turned on, all of the SSH programs on Comet will recognize that there is an agent, and it will be as if you had an agent running there or you had your private key on there. So you can bounce out of Comet. Oops. So let's take a quick look at what it looks like when you use SSH keys with an agent. I'm going to go through adding an identity or adding a key to the agent first. The program is called SSH add. Here I am typing in my passphrase. You only need to do this once, or at least until the agent forgets your passphrase, either because you've asked it to or you've restarted your machine or restarted the agent. And that's it. SSH add, type in your passphrase, and you're good to go as long as the key stays in there. Here, let's try hopping through some machines here. I'm going to log into a host called Scott. The -A argument turns on forwarding. And now I'm going to go from Scott into Comet. And then from Comet, I'm going to go into TSCC. And none of these hosts, Scott, Comet, or TSCC, have a copy of my private key on them. The only copy is on the machine that I'm generating the screen capture from. All right, so if you're all sold and you want to learn how to do this, let's talk about it. Generate a key pair. You only need to do this once. If you already got one, you don't have to generate another private key. Unless, of course, you've lost control of it, and unless of course you lost control of it or the private key has no passphrase. And key pairs have different formats. I don't expect anyone to know what these terms mean, but as you're running through the program to generate them, you may see them. Please use them if you see them. Type is RSA and 2048 bits or more. There are other different key types, and newer software does support them, but older software, which you may find on some older machines, will not. So RSA for compatibility. Let's see what it looks like on Mac and Linux. Fortunately, the software is built in, and here's a process of generating a key pair. The program is called SSH keygen. The type is RSA and 2048 bits. And then here we go. That's what it looks like. Remember to protect your key with a long passphrase. For Windows, it's a little bit different. There is a suite of software called PuTTY. This is a companion program called PuTTYgen, and this is sort of what it looks like. There's a public key block over at the top, marked out in red. Please remember to save a copy of that to a file. It's a public key, which means there's no secrets there, and it's okay. But you'll need a copy of this later. And always Remember to protect your key with a long passphrase. You can get a copy over here. This URL will be available in the slides, and we'll make that available in follow-up material. All right, so you got a private key. Now what do you do with it? You add it to your agent. You only need to do this when your agent doesn't have your key. As I mentioned earlier, the agent will expunge your key upon reboot when you restart the agent or when you direct the agent to remove it. And just so that you don't have your private key always available, try to remove it from the agent when you're done for the day. This minimizes the opportunity for misuse, because like we talked about agent forwarding, or if an attacker is on your machine, you don't want them to just have access to your key and then go all over the place while you're not there. Mac and Linux support automatic removal. Windows does not. Sorry. Just as a side note, there is a native SSH client and SSH agent in Windows, and I don't recommend it because it keeps your private key even after you reboot, and getting rid of it is difficult. Getting the agent to forget your key can be difficult. So let's see what it looks like for adding to an agent on Mac and Linux. The software is built in, and it's one-liner. This example over here, the -T8H, means keep the key for 8 hours. After 8 hours, automatically get rid of it. For Windows, there's another companion program called Pagent. This is one of the dialogues, and it's pretty much the same process, but in a GUI. Hit add key, find your key, you're prompted for your passphrase, type in the passphrase, and you're ready to go. Same URLs before for PuttyGen. Next, now that you've got your private key loaded into an agent, you need to get your public key deployed. Of course, this only needs to happen on servers that you want to connect to, and they just need to know about it. You don't have to do this every time. Your public key goes into this file, at least on comment and expanse, authorized keys, and TSAC, and only add your public keys. Fewer is better, and the emphasis is on yours. Not your colleagues, not your friends, not some random public key that you found on the internet. If fewer is better, one is good. One is the best number. And each key is a very long line. It's one line. It's not multiple lines. Sometimes when you cut and paste things, your terminal or your editor will end up line wrapping. That's going to destroy everything. You need to make sure that it's only one line. So deploying public keys, Mac and Linux, here's what it looks like. There's a helpful utility called SSH copy ID. You just run that command with the host and the username that you want to deploy on, and it'll do the rest for you. Here it prompts me for a password because I don't have a key deployed yet, and then it adds it. Done. Windows, yeah. Are you seeing a trend here? That's a manual process. Back in the PuttyGen, remember that public key block? You're going to copy that key from PuttyGen or from the file that you saved it to, log into the machine with your password, edit your authorized keys file, paste the line in, save it, and remember it's only one key per line. All right, so after all of that, you just use it. Your SSH client will automatically use the agent. Agent forwarding may be disabled by default. It should be. Because an attacker on the server that you log into can abuse your agent if you have agent forwarding turned on. But it's okay to use agent forwarding with hosts you trust, and at least for now, you can trust our machines. But still, you should only have it turned on when you expect to go and hop through a machine. Just don't do it by default. So here's what it looks like on Mac and Linux. Once again, the software is built in. Just run SSH. If you want agent forwarding, use a -A argument. Otherwise, don't. And you're in. And for Windows, there's a program called Putty. You may have heard of that. You may have heard of this one. The agent forwarding controls are a little bit more obscure. They're buried under several layers of menus. Here it's under SSH, where connections, SSH, auth, and there's a little checkbox for allow agent forwarding. And then you can grab them at that URL. As a side note, please use the official URL, the one below. Don't use any random URL that's purporting to be the download site for Putty. Some of them may contain malware. All right, questions?
My decision.
I see that there's a question, if you remove your
Oh.
key from the agent, does that mean you need to enter passphrase again? If yes, how do you automate this for a script? Somebody else responded already for that. Thank you. If you remove your key from the agent and your private key as a passphrase, you will be required to enter it when you re-add it. For automating it with a script, that may be an exception, or it may be a situation where you log in with SSH key forwarding turned on. We can talk about that one afterwards or offline, because I'm getting kind of tight on time. Sorry. All right. So next, let's talk about protecting your account.
Oh, I actually have a question really quick.
Okay.
You said that it's okay to use the same passphrase, and you said that as long as you didn't lose control of the passphrase, you're fine. But how do you know that you didn't lose control of the passphrase and they're just waiting to see that you're not using the same passphrase on other devices or on other things?
Are you saying passphrase or private key?
I'm talking about the passphrase. You mentioned it a lot earlier.
Oh, okay. So the passphrase is something that protects your private key.
Okay.
That one you shouldn't reuse, but it's okay to reuse the key pair.
Okay. But then also, how do you know if you've actually lost control? Couldn't someone just allow you to keep using your key pair and not mention anything?
Yes, that's usually what happens. Is the attacker will make a copy of your key, and then if it's not encrypted, they'll just use it, and you won't know until somebody says, "Hey, your key's been exposed."
Okay.
If you've had a malware attack on your machine, or the machine that has the private key on it, there's a pretty good chance that it got exposed, and you'll need to do some cleanup.
Okay, thank you.
Yep. Okay, so moving on, you logged in, now what? Well, your ability to protect your account doesn't stop here. There's a few items that I'd like to talk about. This isn't everything that you need to do to protect your account, but these are things that I think are really important to keep in mind. We talk about running network services, copy and paste cautions, and then this thing called sudo. So let's talk about services. A network service is a program that performs actions as a user in response to requests sent over the network. An example of this would be a web server. It sits on the machine. It doesn't do anything until a request comes in and says, "Hey, give me a web page," and it returns a web page to the user, or to the thing on the other side of the network. SDSC discourages user-run services on our HPC systems. So if you want to run a service, and such as these are examples, but not the only types of services, please reach out to our consultants and support staff, and we'll help you out with getting your work done and giving you some advice on how to run these things securely. All right, cut and paste. So cut and paste instructions are common. You may have used them to get here. It kind of looks like this. There's some text, and it says, in order to do this, cut and paste this into your terminal. Well, be careful. The commands may do something that's inconsistent with the instructions. So please take the time to read what the commands are and convince yourself that you understand what the command and its arguments do. It's also possible that the website that you're copying the commands from can instruct the browser to change the contents of the clipboard as soon as you've copied the text to the clipboard. So it might look normal, and then you hit select everything, hit Control-C, and then your clipboard gets changed. And you don't know about it till you paste it into your terminal, and then suddenly it's like, oh wait, hey, this isn't installing a package, this is doing something strange. So to be sure, paste it into a text editor first. All right, sudo. SDSC does not grant privileged access to users of its HPC systems. This means anything involving sudo isn't going to work. I guarantee it. So if you have instructions, or if you have instructions or scripts or something like that that involves using the sudo command, please contact our consultants. They'll help you get up and running, and very often the software that you need may already be there. It's just nobody told you how to get to it. All right, questions? Okay, 3, 2, 1. All right. Somebody asks, is use of Globus a problem? I actually use it and got instructions from the Exceed documentation. Globus itself isn't a problem. Let me go back here a little bit. The thing I'm talking about is Globus Connect Personal, which sets up a Globus endpoint, a personal endpoint on the server or on the machine. And that allows you to export everything, that allows somebody on the other end of that, using that endpoint to access any file that you can. And that's the part that we're concerned with. We actually do have Globus endpoints, and those are perfectly fine to use. They're configured for security. Okay, next. So what about my data? We're talking about accounts, but what about my data? Well, you control your data. But there are still some things that we need to talk about. We'll talk about sensitive data, file permissions, and data corruption. So let's jump in. Sensitive data. It's a bit of a touchy subject, and it's like, what makes that data sensitive? In our case, what we're concerned about is data that has regulatory compliance requirements. For example, HIPAA or FERPA or ITAR. And there's data that has privacy or financial implications. So these are things like patient data, or if it's or generally anything that if it's exposed is going to cause us to lose, us or the university or your organization to spend a lot of money cleaning up, like breach notification, doing things like breach notifications or fines. And also data that has contractual obligations. If you had to sign a contract or a DUA to get a hold of that data, it's probably a bad idea to put it on our HPC machines. See, our HPC machines are not designed to protect sensitive data. And if there's a breach involving sensitive data, everyone is going to lose. It's not just us, it's not just UC, it's the entire academic community, especially if it's a big one. So please don't bring sensitive data into these environments. Talk a little bit about access controls. You may have seen this with permission denied error. You try to create a file or remove a file or directory, and you get this permission denied thing. And way in the back of your head, you're like, oh, wait, I had a colleague or a friend or something. They said, just type this command and it makes everything go away and it works. And it's what it does. You ran the command and now you can create your file. Is it fixed? No. No, it's not fixed. No, please don't do this. This is bad. Just don't. It's bad. Don't do this. Here's why. So we all make mistakes. And if you do this, somebody else's mistake can become your mistake. The command the command that you just typed, or in the previous example, it sets what are called world writable permissions. That means anybody on the machine can make changes. Anybody. So here we have an example. Notice the nobody. It's a completely different user. They're not paying attention. They're distracted. They may be tired or sleepy, whatever. And they make a small mistake. Do you see the oops? And it's here. It's right there. There's an extra space. If the person typing this command hit enter, your data would be gone. And as an aside, not everyone has seen this presentation, so please don't go and try it in real life. It will work. It will delete people's data, and we're all going to be upset. So let's try and digest access controls a little bit more. Here's a close-up of some permissions. And they're broken down into 3 major categories: permissions for the user, permissions for the group, and then permissions for everybody else. And each category has 3 permissions. There's read, write, and then execute. And don't worry about the T, pretend it's an X. We'll talk about that later. And those numbers are important, by the way. So continuing. How do you pick those numbers that go after chmod? Well, there's 3 digits and 3 categories, and they do correspond to each other, user, group, and other. And then each digit is the sum of the value of the desired permissions. So remember those numbers, read, write, execute, 421? Yeah, those. You sum them together and create, and that's the value that goes into the digit. So as an example, the user can read and write, the group can read, and everyone else can do nothing. Well, read and write, or sorry, read is 4, write is 2. That's gonna be 6. Then there's 4, and then there's 0. And that becomes chmod 640. I have no idea how to deal with that. Excuse me. I'm trying to turn down my volume. All right, so next up, you may be in a situation where you need to grant write access to a collaborator. Make sure that you use group permissions to grant write access instead of other. So remember that group in the middle, that's what the group thing is, the group permissions are for. The chown command can change the group ownership of any file or group to a group that you're a member of. And this is kind of how you use it. It's a chown colon and then the group name and then the file or the directory. So for this situation, you and your collaborator, hopefully you have a common group. The command id-a can help you find a common group. For example, here I'm listing the groups for my user. Here is an example of what that's going to look like. So log in the comment, I'm going to create a file called mtcollab. I'm going to try and collaborate with Mary. And right now you can see that it's owned by me, it's owned by a group called Ops 100, and she won't be able to write into it. So I'm taking a look at the groups between myself and Mary, and we see that SDS 154 is common between the two. So I'm going to go and set the group ownership for mtcollab to SDS 154. Kind of like that. And then now you should see that it's changed. But she still won't be able to write because there's no write bit set. It goes RWX R-X. That dash means there's no permission there. So now we've fixed the permissions. And then now SDS 154, which is the group that Mary's in, can also go in and write into mtcollab. And I've removed the permissions for other because nobody else has any business looking in this directory. So I made a minor omission. So in this previous example, the files and directories that are created in mtcollab, they may be owned by a different group besides SDS 154. Like if I wrote a file in there, it would be owned by me and group Ops 100, and that can make modifications of those files or directories a little bit difficult. But there's a solution to this. The omission is that there's an additional digit to the left of the chmod user permission. So you saw 3, there's actually 4, but we usually only do 3. The 4th one deals with attributes, and these are the attributes. It's set UID, set GID, and sticky. We only need to concern ourselves with the middle one, the set GID, and what that means is if that attribute is set, if the set GID attribute is set on a directory, then any files or directories that are created inside of there are going to inherit the group ownership of that directory. So actually the permissions in the previous example should be 2770, which would set the set GID flag on the mtcollab directory, and then any files that are created in there will also be owned by the group SDS 154. They're probably wondering, like, what about default permissions? So how do you decide what the default permissions are? Is it why isn't it always world writable? Why isn't it like nobody has access to files? Well, the default permissions are set by a thing called umask. It's a command. You can try running it and see what it produces. The umask settings are persist for the duration of your login and are inherited by any processes that you run. So most people, you can put it in like your batch profile and then not have to worry about it. By default, our permissions allow you as the owner to do everything, and then group and everyone else can only read. So how do these things work? Umask permissions, they're very similar to the chmod permissions. and they have the digits. The digits in them correspond to the same category: users, group, other, and attributes. So start with mentally, let's take a look at how this works. You start with all permissions granted for all. So you want to create like a directory or something. They start with everyone can do everything. And then the UMask gets applied, and any permissions present in the UMask are removed from that set. It's a little hard, it can be a little hard to conceptualize. So let's just look at a couple of examples here. First example is by default, the user can do all, and the group and other can only do read and execute. That would be UMask 0022. The 2 and 2 being, the 2 corresponds to write. And you can see that we're removing the write privilege from the other and the group. Another example, by default, the user and group can do all, and other can only read and execute. This would be appropriate if you're doing like collaboration using group writable permissions. So that one, we don't remove any permissions from the group type or group category. And then finally, to be a little bit more secure, you remove all of the permissions from the other. All right, questions? I see there's an ongoing discussion about Globus, and it looks like it's being addressed. I'll defer on that. We can go over that afterwards. Any questions about permissions? Okay, well, moving on to data corruption. So, data corruption. SDSC does have technologies and does have technologies in place that help prevent or detect data corruption, but it's still possible to end up with corrupted data in some circumstances. So please consider including integrity checking as part of your workflow. And for applications that do not inherently do integrity checking, you can try one of the digest tools that we're going to talk about next. What does a digest look like? What is a digest or a cryptographic digest? It's an algorithm that takes an arbitrary amount of data from 0 bytes to however many bytes you have, and produces a very small fixed-sized string or sequence of bytes. It's called a digest, and this has some interesting properties. The digest is reasonably unique for every input, so hopefully for every input there's a unique output. Of course, pigeonhole principle means that there's eventually going to be a collision, but those are rare. The small changes in the input cause big changes in the digest. So if you have an input and you flip 1 bit, the digest is going to look completely different. Even at first glance, it's going to look completely different. You'll be able to say, oh yeah, they still match at all. And this makes them ideal, and consequently, this makes them ideal for detecting corruption. So here are some tools. It's called they usually end in sum: SHA-56 sum, SHA-1 sum, 95 sum. Those are for Linux. On Mac, they are known as SHA-sum and MD5. In Windows, I don't have any advice there because I don't think they have any built-ins, or at least they didn't. Maybe they were added. Here's an example of working through or using a digest to create, or using a digest to detect corruption in our MT collab directory. So I'm going to create a text file with a simple string in there, hello there. And then we're going to commute a digest on it, and then check it, and then corrupt the file and check it again and show that the digest does detect corruption. So greetings.txt, it does contain hello there. We're going to compute the SHA-256 sum, and then save its contents to, or save the set of sums over in a file called /tem/mtcollab.manifest. The name of the file is arbitrary, and this is what it looks like. On the left column is the digest, and on the right column is the name of the file that created the digest, or whose contents was used to generate the digest. And there's a helpful -c argument for check, and you see that everything has checked out okay. Now let's go ahead and deliberately corrupt the file, and then rerun the check. And then we see that it failed. So SHA-256 sum use a digest. Digest did not match what the digest in the manifest file did not match what was on disk, and threw a warning or an error. All right, last break for questions.
It's a little more of a theoretical question, but can you work backwards? So,
I'm sorry, can you repeat that? I had my volume down.
Oh, sorry. I said I guess it's a little less relevant, but I guess I was wondering if you could work backwards from the digest. Probably not, right?
Not in the sense that you may be thinking. The other property of a digest is that given a digest, you can't reverse engineer the data that was used to generate it. However, there are databases of passwords or strings that they've run through digest and then established a mapping of here's the data that we put into the digest, here's what the digest is, so you can query by digest and see what data was used to create it. They call it a lookup table. But aside from using a lookup table, yeah, you can't take a digest and then use it to recreate the data. We did not stumble upon a really awesome form of data compression. Okay, anything else?
Oh, one more thing.
Yeah.
Actually, how likely is it for data to be corrupted, and what causes the corruption besides just mistyping things? The only thing I know of is dirty memory. I thought that gets flushed really often. So, or is it always just a problem in transferring the data over the supercomputers directly to our local machines?
That's one place. That's one place that you can get data corruption. Yeah. So we protect the data once it's written to disk. In most cases, it's protected once it's written to disk. However, in the process of being being transferred to the file server to the machine that you're using the data, that data can become corrupted. It's very unlikely, but we have had not here at SDSC, but within the research community, instances of network failures where like the router that's handling the data as it flows through it had bad memory and was corrupting packets as they pass through. Bad hardware can corrupt data. So if you have failing memory or failing CPU, your machine's too hot, something like that, bits can get flipped. And it's also possible that if an attacker, or if you left like your files world writable, or an attacker got into your account, they may have a goal of corrupting your data so that your research is invalid, or they may just go and say, we're going to corrupt your data and put junk in there, and then we'll save a copy, put junk or delete your data, and say, well, if you want your data back, you need to pay us money. There's all kinds of ways that you can get data corruption. I can talk about more of those later, but yeah, it can be pretty crazy. But fortunately for us, the probability of encountering corrupted data is very low. But still, with research that can be referred to for many years to come, it's a good idea to make sure that we're working with good data so that we don't invalidate a whole bunch of research later. Okay, anything else? All right, let's move on to closing remarks. So, disclaimer, this is not a comprehensive presentation, and rather awareness is the goal. So what I'm hoping is that afterwards you'll be able not necessarily to go and say, okay, I know exactly how to create an SSH key and how to use it, but rather, hey, there's this thing called an SSH key, and he said something about you shouldn't run it without a passphrase, so I need a passphrase, and I'll figure out how to use that. And then, oh, there's this agent thing. I want to make sure that, or I hope that when you go away or when you're done, that you just remember that there's these things, and then you can talk to people about how to use them. And also importantly, there's these things that you shouldn't be doing. In security itself, it's a really complex domain, and it can't be condensed down into a single slide deck. So rather, I just hope that we can develop a security-focused frame of mind. Now, some may call it paranoia, but it's actually, I like to think of it as preparedness. All right, thank you very much. Thank you for your time, and if we got any time left, I'd like to go off the record and do a follow-up.
Great, thanks very much, Scott. That was very, very interesting. Yeah, so I'll go ahead and stop the recording, but if anybody wants to stay on for some additional details that might not be appropriate to be recorded, you're welcome to stay on. Thanks again, everyone, and have a great rest of your day.